So Stephen Salter was a pioneer in marine cloud brightening as a local and global cooling method. Recent comments have included from James Hansen and George Soros, recognizing Stephen's work in MCB engineering as showing high potential to deliver a fast, safe, cheap, and effective contribution to cooling the planet that could be publicly acceptable and relatively simple.
Hello and welcome to the Climate Emergency Forum. I'm Herb Simmons and I will be your host today. We're here today for a very special discussion on the legacy and promise of a very special man, Stephen Salter, who sadly passed away about a month ago, who is a professor of engineering at Edinburgh University. And we have people with us who have worked with and have known Stephen for many years, who'll be able to reflect on his life and on some of the extraordinary inventions and challenges that he overcame. So with that, we thought maybe the first person to have speak is Stephen himself. And so what I'd like to do is turn it over to a video of Stephen that was recorded at the Conference of the Parties, the big climate conference in Glasgow 2 years ago, where Stephen spoke. And in addition to other panelists that you'll hear, we're also on that panel. But for now, let's listen to Stephen talk about marine cloud brightening.
Thank you. The greenhouse gases are increasing the amount of heat we're retaining by about 1.7 watts per square meter. And the sun is putting in about 340 watts per square meter over 24 hours averaged over the Earth. So if we could increase the reflectivity of the Earth by 0.5%, we've solved the problem. And one way we might be able to do this is to change the reflectivity of clouds, and that's what these ships are doing. They are squirting out very, very small drops of filtered seawater, 0.8 of a micron diameter. These going out horizontally, but because of the cooling of the evaporation of the air, and they evaporate, they will be going down. They won't go into the sea because the air is not going into the sea, and they're glued into the air. But they'll warm up from the sea, and then they'll get up to the cloud level. And the job they can do is really quite useful. They are cooling. I've got different areas here for an El Nino or a hurricane or an Arctic ice. And the bottom line of there is the number of vessels that we would need to work at full power, maybe they won't all be, for doing jobs in different periods. And you'll see that for reversing sea level with 20 years, if we did that in 20 years, we'd need 400 of these ships to do it. And if we wanted to save the Arctic ice, we just want 42 vessels, which would have to do the job in just 60 days, on the other side of midsummer. This is why we have to do it. You can decide what the chances are of putting carbon dioxide concentrations back down. That's the Keeling curve, which must be very frightening. This is the amount of energy that's been going into the deep oceans, and a zettajoule is about twice the total human energy consumption of all forms of energy. I didn't know what a zettajoule was until I started this. This is showing different seawater temperatures over the oceans. Complicated, interesting, and we may need to do different things in different places. That's the separation between the different oceans. Now, the number of dots there is a representation of the total solar input. And if you look at the tiny little thing down there, that's the human energy consumption in all in all forms. That really makes you, it hits you in the gut with the difference between the solar input and what we're actually doing. There is a rather familiar slide, but if you look at this one, you'll notice that the top arrow is going to a rather white bit of cloud, and the lower arrow is really a grey bit of cloud. This chap here, a chap called Sean Toomey, who really started all this business, was very interested in why some clouds were whiter and sometimes were grey, and he was able to fly over them and measure the light coming down from the sun and the reflection coming up, and he could fly into them, and he could scoop up samples of cloud drops and see how big they were and how many there were, what the concentration was. And he produced lots of really heavy algebra, which you can condense into one slide. The vertical axis is different amounts of power or albedo or reflectivity, but the key is the horizontal line, where it's the relative number change of the cloud drops. So you can choose the amount of energy that you want to reflect up and down the vertical lines, whether it's the cloud or at the top of the atmosphere. You slide along until you hit the slope line, and then you drop down, and that'll tell you how much you want to multiply the cloud drop concentration. There is a photograph showing, I've got another copy of it here, showing the effect of larger number of smaller drops being white and the small number of big drops being grey. Those are glass balls, so it's the same material and the same shape, just different sizes. 4 millimeters on the left, the grey one, and about 40 microns, 100-to-1 ratio. This chap here knew all about this, and he suggested that we might be able to cool the Earth by spraying seawater. And his idea. And you'd have thought there'd be a fairly even distribution of drop sizes in the atmosphere, but there aren't. There's 3 different modes, and the coarse mode is not big enough to show on this diagram. We want to spray where the red arrow is, which is 0.8 of micron. That would, if that evaporated down to a completely dry solid, it would be about 200 nanometers, and we think we need a rather narrow spread on that. This is a plot of all the estimates made of all the amount of seawater that's been thrown up into the atmosphere, plotted against the year that they were made, all right? And you can see that it must be a rather difficult thing to measure. The average value is a little blue circle there, and if you look carefully, you might just see a thickening of the black line of the horizontal x-axis. And if we were trying to have 1,000 of our vessels working flat out, full power, they would be producing the thickness of that line. So it's not the amount of water we're putting up, it's the number of successful nucleations, and that depends a bit on getting the right size. That's what they look like again, and that's what the engineering would look like. You won't be able to see any of the detail of that at this scale, but it shows that we are really well ahead in choosing seals and bearings and the thicknesses of all the sections. And they're driven not by sails, but by things called Fleckner rotors. And this was built in 1926, the original ones, and they're now being introduced into quite large ships, and they're saving quite large amounts of fuel. This is a result of some work in Norway, where they were a bit more intelligent than most of the climate modelers, and they decided it would only be a good idea to spray where there were low clouds over the oceans. And what they did was to increase the nuclei concentration by 50%, which is quite a modest change. And you can see there's a really big concentration of cooling right up in the northern areas, which is extremely welcome. And that's on the right-hand map. And then on the left-hand map, you can see what it's doing to precipitation. And you'll see that there's greeny blue bits in the Sahara and Australia and Mexico, and South Africa. So it's increasing the amount of precipitation in the drought-stricken regions. And where it's reducing precipitation, it's over the sea where nobody really cares very much. If there are small islands there, we could perhaps provide them with desalination plant. And another thing we can do is to cool the sea to moderate hurricanes. And that map is showing you where the hurricanes start and where they get bigger. And the ones that get publicity are the ones that hit America. And you see they usually start in the Cape Verde Islands over on the African side. And what we could do would be to have fleets of vessels that were cruising around, starting in November, and through the year, they would be measuring the sea surface temperatures, and you'd adjust the number of them to match the required choice of sea surface temperatures that was chosen by the governments of the countries in that area. No one's brave enough to say, we'll promise you no more hurricanes, but they can say, we'll get you down from 26.5 to 23, and you prepare somehow how close we can get. And there is a table again of all the jobs that we might do. I think these would depend very much on the initial concentration of nuclei and the drop life of the ones that we spray. And I'd like to put a big factor of safety on that, but they're not absurdly out. It's very difficult to get a cost estimate of anything if someone loses their job if they revealed the secrets of a commercial company. What you have to do is to look around for something that's similar in production rate and in power and weight and working conditions. And the only one I've been able to find so far to help us estimate the cost of spray vessels is the Flower-class corvettes that were built for the Royal Navy in 1940. And they cost £60,000. And if you index link that till today, it's about a factor of 50 increased. Chief Scientific Advisor was paid 600 quid a year, R.V. Jones, who bent the beams that were navigating the Luftwaffe. And if we wanted to have a fleet of 800 of those, it would cost about £240 million a year to pay the bank and do the maintenance. And I picked 800 because I'm told that the cost of security for this conference was 250 million. So it would be cheaper to have a fleet of 800 corvette replacement spray vessels than to have this conference.
Okay, now that we've watched Stephen give an introduction to marine cloud brightening and showing a bit of his creativity and imagination, I'm really delighted to have the opportunity to turn now to our first guest, Robert Tulip from Australia. And Robert has a master's degree from Macquarie University and a graduate diploma in foreign affairs and trade from Monash University. Excuse me, Robert, if I'm mispronouncing those names. He's worked for 30 years for the Australian Public Service in international development, including policy and programming across a number of different sectors and countries, especially in Papua New Guinea. He's also been working in climate engineering since 2007, one of the pioneers there, where his work on forest and climate led him to see large-scale ocean-based algae production as a decisive technology for climate stability. And Robert is my colleague on the HPAC, the Healthy Planet Action Coalition Steering Circle. Robert, the floor is yours, and welcome.
Thank you very much, Herb. So Stephen Salter was a pioneer in marine cloud brightening as a local and global cooling method. Recent comments have included from James Hansen and George Soros, recognizing Stephen's work in MCB engineering as showing high potential to deliver a fast, safe, cheap, and effective contribution to cooling the planet that could be publicly acceptable and relatively simple. These efforts to mitigate global warming and cool the planet are a first step on the path toward restoring a livable climate. Over the last years, Stephen actively contributed to regular online discussions, both by email and through Zoom calls, with the Healthy Planet Action Coalition, the Planetary Restoration Action Group, and the geoengineering Google group. Stephen's wisdom and experience brought immense practical and strategic insights into these forums and led to the formation of Re-brightening.org as one way to continue his work. We greatly miss his presence with us. Until late last year, Stephen was actively looking forward to working on MCB technology at the Lothian School of Technology in Edinburgh that he had just established, whose core mission includes supporting marine cloud brightening. Stephen worked with atmospheric physics professor John Latham, and that gave his proposals for MCB a rigorous scientific basis, showing how adding submicron aerosol particles of sea salt to marine clouds could slow and even reverse global warming. MCB could have a leading role in delivering key climate objectives. MCB could slow polar melting that's contributing to extreme weather and sea level rise. It could help to reduce storm intensity and protect biological and human systems that are endangered by increasing heat. The first focus has to be to find the best way to generate MCB particles at scale. Stephen's Lothian School of Technology aims to have a key role in this global effort, building upon Stephen's research. On behalf of Stephen's many supporters in the MCB community, I thank the Climate Emergency Forum for convening this discussion. I hope it can reach a wide audience about the urgency and importance of sunlight reflection as a primary cooling approach. Sunlight reflection is a lever we can use for direct climate cooling, while the slower work on removing greenhouse gases continues. MCB could be the most feasible starting point to re-brighten our planet, thanks in very large measure to Stephen's courageous and brilliant work at the frontiers of science. Thank you.
And thank you, Robert. Like you, I had the opportunity to interact with Stephen, not in real life, but on Zoom at some of our Healthy Planet Action Coalition meetings. And whenever I moderated a meeting, when I saw Stephen's face come on, whether inwardly or outwardly, a smile came to my face because I was always so excited to see him, because I knew he was usually fairly quiet, but when he spoke, there was wisdom, often humor, and it was something to remember, something I'll never forget. Rob, I wanted to ask you, Robert, certainly Stephen and all of us who are working on climate intervention run into many challenges with respect to how it's viewed by the public. Did Stephen run into challenges? And if so, how did he address those? I know that's a big question, but at least briefly, if you could address that.
Look, just massively, because there's a general view that emission reduction alone is sufficient to address climate change. And that view is in conflict with the observation that we need to physically cool the planet to restore the lost albedo that's collapsing in the climate. And so Stephen faced a lot of opposition. If the world had listened to Stephen 10 years ago, then many of the extreme weather events, such as I think particularly the hurricane that hit Acapulco recently, they could have been really mitigated. Let's hope that we're able to get the message out and advocate and engage in that conversation.
Thank you. I mean, that's one reason why we're doing this program today, not just to honor a man, but to honor an idea and a potential for the future that really has extraordinary potential benefit for mankind. Next, I would like to introduce Professor Peter Wadham. Peter, welcome. It's so nice to see you here today. And I know you've known Stephen for a long time. You've been in this work a long time. You've been as much of a pioneer in terms of Arctic ice and atmospheric and ocean physics as most anybody on the planet. In fact, in preparation for today's talk, I went to Amazon to see your book, Farewell to Ice. It had 254 reviews and only 3 of them were negative. And I'm trying to track down who those 3 people are. But it was truly extraordinary, the degree to which your book resonated with people all over. You know, as an academic, you're used to being peer reviewed by your fellow academics. But when you put a book out like I've done and like you and others have done, your peers or anybody on the planet who chooses to buy your book, and they have definitely given you a thumbs up with that. So I'm delighted to have you here. And I really turn it over to you to talk about your experience with Stephen and anything else relating to his life and his work that you'd like to share with us.
Okay, well, thanks. What I had planned to talk about was something a little bit off beam as far as the central aspects of Stephen's work is concerned, which was Stephen and the salter duck. And I don't know if anybody knows the story of the salter duck, but it was one of the most important pieces of work that Stephen did in the early days. So I thought it deserved a mention. It was really an early attempt to be able to do energy generation from waves. These days, you've got lots of it going on. That is to say, if you think about Britain, you've got an outfit called EMEC in the Orkneys, which is European Marine Climate Centre, and it's a long stretch of coast with extraordinary things. It's got plugs, like a plug-in system, where if you're developing a system for producing energy from waves, you take along your system, take a big cable, plug it into the cliff, and then you can record all the data you want forever. It's a marvelous system, and one wishes it existed in Stephen's time, because he was the pioneer of actually getting energy from waves. So to tell the story very briefly, at the beginning of in 1973, there was a sudden government thing where they decided that they wanted to develop ways to get energy from waves. Nobody had done it before, so Stephen immediately leapt to do it, and he developed a thing which was a line of weighted systems which had inside them gyroscopes. So every time that this weighted system hit, every time a wave hit, it moved moved all the things inside, which were duck shaped, which is why it's called a salter's duck. Then that caused the gyroscope rotors inside to move about and generate energy. So it was an energy highly successful. It was approved by the government, and it was going to be the basis for wave energy in the future. And so this looked wonderful, but unfortunately, it was a victim, as so many things from Stephen have been, but it was a victim of malice and evil. And sadly, what happened was that there was an organisation in Britain called the Energy Technology Support Unit, which sounds good. It sounded as if they were going to support things. But of course, this is Britain, so they weren't supporting it. What they did was try and stomp on it, because they were run by the UK Atomic Energy Agency, and they wanted to stomp on everything that wasn't atomic energy in those days. That was the thing. So they stomped on that. They also caused about £9 million that was given to Stephen to help that work. They caused it to go astray, so he never got it. And the result was Stephen's duck died. And what I'd loved, ambition that I'd like to do before I die, is to resuscitate Stephen's duck and have it working again, maybe plugging it into the cliff face, and see if the system, which was by far the leading contender for wave power in those days, to see how it functions. And I have a personal interest there, because at exactly the same time as Stephen was doing this in 73, I was working on my thesis, and it was on wave power machines. And so I had my own personal sort of pathetic duck, which was a kind of a system with various jointed rafts. And my supervisor on this was a very famous guy called Michael Longett-Higgins. And I found, to my surprise, that as I was in thinking I was getting my thesis finished, suddenly a paper appeared under the authorship of Michael Longit-Higgins, which was my paper on the using this method of jointed rafts. So that was normal in those days. You pinch your students' work. So, okay, so brief history of Salter's duck. It's there. It's still probably the best potential wave machine around. Nobody's doing anything about it because it's long thought to be extinct. But there is now equipment to be able to do however much testing you want with a large stretch of cliff in Orkney, which has now become Wave Research Cliff. So in honour of Stephen, I would like to see Stephen's duck reactivated and brought back from the dead.
Well, thank you, Peter. That's a story, I guess, that sadly is all too common, that those who stick their necks out, so to speak, those who invent things that challenge vested interests are too often shot down and repressed. But in this case, the good potential news is that the idea is there, the duck is still there. And to use a terrible comment, let's hope we can get the duck to quack. And for that invention to come to life, maybe those who are on this call and those who are listening can help work with you, Peter. That would be another extraordinary legacy that I'm sure Stephen would be smiling at from wherever he is. So thank you for that, Peter. And I want to turn now to Paul Beckwith. Paul, I've known you for a long time through your videos. You're probably the most prolific and indefatigable videographer of climate information in the history of mankind. I know I'm understating it. I know, I realize, but anyway, and probably if it wasn't for watching some of your videos years ago, I may have decided to, work on something much less interesting and productive. I'd probably be happier, but nonetheless, I think many of us owe you a great debt of gratitude. You're a climate systems scientist. You've taught at Carleton and the University of Ottawa, and you've gotten to know Stephen as well over the years and his work. So I turn the floor over to you.
Thank you. I guess my question to you is, how come you didn't put me as a co-author on your book if I was responsible for you going in the field? But anyway.
I've got a next edition coming out. We can talk about that.
So, Stephen, yes, worked, with Stephen for many years via emails and Zoom calls and social media and other things, followed all aspects of different interventions that we can do to possibly cool the planet, because obviously slashing fossil fuels is a necessary and required, but I talk about a three-pronged approach where we need carbon dioxide removal, and to buy time to do those things, we need solar radiation management ideas. So, Stephen was a, very creative and brilliant engineer, inventor, loved to tinker, had many interesting discussions, mostly on the marine cloud brightening aspect. But I think the Salter duck, as Peter was pointing out, was way ahead of its time. It was being invented and produced and trialed, at a time when the world was in a deep energy crisis, right? The Arab oil embargo, et cetera. So there were a lot of projects that were pushed forward at that time and then scrapped, unfortunately, when the embargoes with oil ended, and we became a much I don't know what oil production was back then. Maybe somebody can look, but it was, we've just continued to accelerate in oil, gas, coal, fracking, etc. But anyway, so Stephen, luckily I got to meet him when I went to the climate conference in Glasgow, and we did a press conference on marine cloud brightening. And I remember we go up on stage, and wherever Stephen traveled, he would carry a bunch of different jars of different glass beads, starting with very, very tiny, minuscule glass beads, which kind of with the idea that they would represent these low-level clouds that were created by pumping seawater through nozzles and using the salt crystals as cloud condensation nuclei to generate very, very small cloud droplets. So these clouds, of course, would be very, very long-lived, and they would be highly reflective. So always had his grayscale sheet showing different reflectances from different particle sizes. Of course, when you go to very large particles, like in those type of clouds, rain out very quickly and have short lifetimes. So he gave a very, very good presentation. And I think part of that 11-minute video is actually from that press conference. When you meet Stephen, he came across as a very, very soft-spoken, but his ideas were very, very powerful. He reminds me of Q in James Bond, actually, the James Bond series, the inventor that comes up with all kinds of amazing gadgets in the James Bond movies. So, I may have called him Q accidentally a few times. Anyway, he's going to be missed, but his work, I think, is going to continue for a long time. Just as one last thing, in USA Today and in Reuters news agencies within the last week, I've seen articles on marine cloud brightening. Mainstream scientists are getting so concerned about rapidity of climate change that they're actually looking seriously at things that Stephen spent most of his life working on, like marine cloud brightening. That's a very powerful thing. I mean, these ideas will work to cool the planet. We just have to scale them up and use them.
Thanks, Paul. What do you see as the biggest challenge or obstacle in taking this extraordinarily promising idea that has, through Stephen and others' work, has had a lot of engineering done on the kinds of ships? The work is being done now on nozzle size and salt particles and atmospheric physics and so forth. What's the biggest challenge to take it to the next step in your view?
If we could get these ideas more widespread, first of all, so people see them, and then I think the real push to get them scaled up would be to get, if we could get some of the people in the military industrial complex to say, okay, climate is a huge threat. What are we going to do? Put lots of money into developing these ideas, advancing the engineering and deploying them. It's something like that the military could do in several years if they set their minds to it, if they were given that direction by political leaders. So I always argue, as bad as climate is, if we put the $1 trillion US military budget into addressing climate change just for a few years, we could make huge headways with ideas like MCB and plankton pasture restoration, all these other different things.
Thank you. Well, since I live literally 300 feet from Washington, D.C., one of my neighbors works at the Pentagon. Maybe I'll have a chat with him as soon as I see him next time, and I'll let you know. You never know. It's one conversation with the right person can turn that knob. And I think the more people that are having those conversations, the more likely that knob will be turned.
All journeys start with one step, right?
And our next step will be for me to invite Professor Wim Rampin from Edinburgh to speak. Wim, you are as I understand it, the chair of energy storage at the Institute of Energy Systems at the University of Edinburgh. I understand you're from Canada. We had a little conversation earlier. We've got Canadians, Americans, Australians, and Brits here. It's delighted to have you. I understand you worked with Stephen off and on for many, many years, and we're eager to hear your views of Stephen and his work.
Yeah, I thrilled audiences in Oakville, Ontario by moving to the UK. I first met Stephen in 1978. I got off the train here in Edinburgh looking for a job, made my way to King's Buildings where he was. I knew that from a magazine. Walked into the engineering building, pushed on a door. There was a guy called Jamie Taylor. And I said, Jamie, I'm looking for Stephen Zolter. And he said, I'll call him on the phone. So he rang him up. Jamie said, I got this guy looking for you. He said, Stephen said, tell him to go away. And after about 10 seconds, he said, unless he wants a job. So my entire career hung in that 10 seconds, but there we go. We had the most amazing team that I was, I think, about the number 6 person to join back in the 1970s, working on the duck. And we grew, all the right people came and found us, and we formed a team, and it very much followed the zeitgeist of Stephen, who was a man with incredible range of knowledge. He could be standing at a lathe and turning apart and saying, well, how many turns of rope do I need to go on this drum so that it'll have the right amount of friction, and he would do a calculation while he was machining the part. And that was Stephen. He was very good at a lot of different things, an incredible range of knowledge. And it didn't, unlike most people who are either intensely practical or very theoretical, he combined the two. Very unusual. So he was able to synthesize, he was incredibly creative. He could design experiments. He could build things himself. He made one of the very earliest touch screens in the early 1970s, using completely different principles than the ones we have today. It was for children, so that they could work out what children were looking at. I mean, this was the range of things he could do. He hated silos and demarcation, and he was very interested in training students, and in fact wrote a paper about training that was completely turned everything upside down. He was loved by some of his students, who love him even to this day, and feared by others. A typical example of a Stephen exam question: how far would a person have to fall to properly heat the water in a bath in which they landed? This illustrates the fact that Stephen wanted you to come up with actual input numbers. Most engineering exam questions, you get 4 numbers and work out the 5th. He wanted you to go far deeper than that. A result of the facility he built up was that we had machine shops, we had all these interesting people, and when wave power ended, about 3 different companies came out of it, and together we've created 1,000 man-years of employment in Scotland in high-quality jobs, 300 million pounds worth of direct input to Scottish economy, and much more when you work out how much that drips down into the broader economy. Stephen and I searched for a building for about 3 years to launch his institute. In fact, in last May, we bought a 30,000 square foot building. He knew he was already very ill, but he was still, at the end of his life, keen to erect even more building on the same site. So we founded something called the Lothian School of Technology, which is a continuation of what he did accidentally. It's an incubation place for low carbon technology companies led by engineering entrepreneurs, and it's a means of training engineers by actually doing engineering. It's a home for the long forestalled work on marine cloud brightening. Thanks.
Thank you so much. What a wonderful combination of qualities and stories you've told about Stephen and his work. Wynne, if I had to ask you a question, in your ideal world and that of your colleagues, where would Lothian and the work that all the folks are doing there be in 3 years or 5 years? What might it become?
Well, I think it will train a new generation of engineers. I think this is a general problem in academia, in that in order to become a professor or an academic these days, you have to have a fairly continuous run of remaining in academia. And it's not really what engineering is about. Engineering is about doing, rather than studying one small thing, becoming an expert on one small item. And that's where Stephen really excelled. He was able to look at he had a much broader canvas to work from. And he created people, or his students, effectively, his colleagues, went out to found companies in all different areas. So I think the first thing is that we need to train a lot of people like Stephen to solve all these problems. And the second thing is that the facility incubates companies that are working on marine energy, quotient, energy storage, SynchroStore, Flowcopter, making man-carrying drones that could literally displace helicopters for about 1/10 of the price. And Edinburgh Designs, it's building wave tanks for modeling wave energy around the world, so including in Canada, actually, and the US. So these are the kinds of companies he wanted to incubate, and the kinds of people he wanted to train up. And I think it's going to be a great success.
That's an extraordinary vision, and I'm sure the folks there and you and others will make sure that the world is kept abreast of all of your accomplishments, and ask for whatever support you need from the rest of us to make that vision a reality. Thanks for your work on that, Wynne. I'd like to introduce now Dr. Alexandra Price. She is a research associate also at the University of Edinburgh, the background in experimental modeling of wave energy converters. She finished her PhD on wave energy control theory at Edinburgh in 2009 and has worked principally in commercial R&D of wave energy. And I know you, Ali, I've seen a couple of your emails because I'm on the Re-brightening list, having attended some of the early meetings, and I know you've been directly involved and connected with Stephen and his work, and we look forward to hearing from you as your perspective on Stephen and his legacy.
Okay, so yeah, thanks for the introduction, and thanks, Wynne, for reminding me of that exam question that Stephen set. So I remember that as a third-year undergraduate at Edinburgh University. More recently, I work with Stephen archiving his work on the wave energy program. So I got an insight into all of the politics behind that, and I also got to see the really broad spectrum of his inventions. Really huge amount. I mean, you can't imagine, just shelves and shelves, and each little meter was a different invention. Really quite astounding. But one of the things I realized from that work is that although he came across as someone who was kind of all head and no heart, a lot of his work actually came from the direction of what would benefit humans. Often his way of thinking was at odds with the moral codes or what was happening at the time. So, for example, back in the kind of late 70s, nuclear was something that was very, very, very popular, and it wasn't something that it was a bit of a kind of left field greeny thing to be kind of anti-nuclear. And a lot of his wave energy work, a lot of his sentiments in the things that he wrote were anti-nuclear, which was politically dodgy at the time when he was funded by ETSU, and ETSU was staffed by lots of ex-nuclear people. So that was just an example of where he was, I guess, ahead of his time. And the marine cloud brightening is another area where he is ahead of time, and where he has started from the point of view of really cutting through all of the noise that's in our culture and stepping back and seeing what's important and what needs to be done. I mean, he's very, very much aware that it's controversial, and that wasn't something that particularly would stop him from what he was doing. It wasn't something that he ignored either, but it was just the ethical direction that he was coming from was for him the most important. So that was just the main thing that I wanted to throw in there. Thanks very much.
Thank you, Ali. Let me ask you a similar question to that I asked Wynne, which is, given your work and your connections with Stephen and all the other folks, ideally, what do you see best case in the next several years coming out of this legacy of work at Lothian and so forth, and your own personal work there?
Oh my gosh, best case is that the really good students that we've still got, that we have at the moment, who are just doing student projects, are actually employed engineers, and that we have done extensive lab tests in collaboration with universities from around the world to get the information that is needed to put into climate models to de-risk the problem, so that we can make better decisions collectively about this technology. And I suspect, not that I hope, but I suspect that in, say, 3 years' time, if the weather continues doing what it does, and if the concerns of the scientists about the 10-year delay between carbon dioxide emissions and temperature rise, and indeed between carbon dioxide emissions and sea level rise, if these concerns of scientists are correct, then I suspect in 3 years' time, the demand for this technology is going to be really high. And hopefully that will open up conversations, and there will not be as much of a split, of a black-white split, because at the moment I would say that public opinion is really quite divided, and there isn't a really good conversation about the grey area in between. And partly that's because I believe most people haven't realised actually what a sorry state we're in and how dire things are.
Well put, and an admirable vision, and one that we all hope, at least those of us here, and hopefully more and more people becomes a reality in the next few years. The world of gray is the world that has to change to a world of white and cool and bright. And with that, before we go into a discussion, I want to turn it back to Robert Tulip, speaking of bright, who will talk about a new entity that he and his colleagues have been involved in, and with Stephen initially, that involves re-brightening our world. Robert?
Thank you, Herb. So Re-brightening.org was founded by Stephen Salter and colleagues last year to build a coalition of support for his work on marine cloud brightening. He led the project design discussions to develop the Re-brightening funding proposal. And I was able to stay with Stephen at his house in Edinburgh for 4 days last June, just working in detail through what is needed. Stephen came up with 4 initial areas of work. The technology to generate the submicron salt spray is a major focus, and he's invented a spray tunnel, which is now under construction at the Lothian School of Technology. Then there's also computer modelling of the optimal MCB deployments and the risks. Public advocacy is a major theme, and bringing things together in project management. So the Lothian School of Technology is working closely with Re-brightening.org to support research, to deepen the network of contacts, and hopefully leading to MCB field tests. A priority for Re-brightening.org is to rebut the widespread misinformation that has made many people wrongly question the need for MCB. We aim to show the extreme peril we now face from global warming, that it's far worse than any risks that could come from a well-governed MCB program. Nations need to take concerted, combined action to support sunlight reflection methods, including MCB. The world has darkened by about 2% in recent decades, and that warming impact is equal to 50 years of emissions, according to James Hansen. So, re-brightening the planet can restore the lost reflectivity and slow climate impacts. We are looking for volunteers to help us get the message out and raise funds and awareness and support. At the moment, Re-brightening.org is just a small informal team with some excellent expertise and networks. We're fiscally sponsored by the Climate Foundation, led by Dr. Brian von Hertzen, so we're able to accept donations. Please visit our website at Re-brightening.org. We see a high need to organise more effectively to bring MCB to public attention as a necessary priority measure to counter both global and local warming. Thanks, Herb.
Thank you, Robert. I think it's fair to say that rarely has there been an organization with as huge a potential impact on the world that is so tiny as yet. And so the key is leverage, to use the intellectual leverage that you have and the credibility and importance of the idea and the potential impacts on the lives of literally billions of people. It's easy to speak and sound like one is being grandiose or exaggerating and talking about the potential benefits of MCB and similar kinds of approaches. But I think, speaking, I think for all of us, there really is almost unlimited and necessary potential to help us transform what we now have into something that's much closer to a safe and healthy climate. I want to thank all of our speakers today who presented 5 different perspectives on Stephen and aspects of his work. We have a few minutes for open discussion, and I'm just going to turn it over to whoever would like to follow up on whatever anyone has said, or fill in on anything that you still want to talk about.
One of the things that I wanted to raise was the amazing design that Stephen Salter made for autonomous vessels to deploy marine cloud brightening. And his study, together with John Latham, of what will be needed to actually cool the planet, indicated to him that a fleet of autonomous vessels would be able to go to the best place to add submicron salt particles in order to best re-brighten the clouds. And one of the issues there is that Stephen also recognised that that's a fair way down the track, and there's a whole series of steps that are needed before we can get to that sort of point. And so one of the problems that we face is that the salt particles need to be so very tiny. So a micron is 1,000th of 1 millimeter, and that's about the size of particles that are needed. And there's a bunch of people around the world, in University of Washington, in Cambridge University, here in Australia, working on the Great Barrier Reef, that are studying this technology. And our work, in cooperation with the Lothian School of Technology, has really great potential to take this forward. And once we've got the ability to prove that we can make the salt aerosol in the right form, then I think we're going to see quite a change in the public perception, because we'll be able to say okay, here's something that we can actually do to mitigate extreme weather. And with the worsening of hurricanes and tornadoes and typhoons and cyclones and floods and droughts, there's a really high potential. It's something that can also link into the machine learning space, just understanding the climate system and what's needed, and the importance of higher albedo, reflecting more sunlight back to space, and marine cloud brightening is possibly the best way to do it.
No, I just wanted to make the point that somebody had made earlier on, that how do we, to help this along, how do we bring it about? And the problem is, what do we do about this, the kind of lunatic type opposition? Because the opposition to doing anything on marine cloud brightening is not logical and it's not rational. But when you look at the people who are doing it, they're sort of weird characters. And in fact, one of them is a professor at Oxford University, although he looks like and sounds like a loony. And yet people like that are in positions of extreme importance as far as the world is concerned. How do we get around this kind of block which has got entered into the world?
Well, I think with marine cloud brightening, I mean, one of the big advantages of this technology is that it uses salt. I mean, what could be more innocuous than salt? I mean, we can use one of the sprayers, you know, in a fast food restaurant to put salt on our fries if we want. Like it's just, I mean, whenever there's a wave breaking, then some of the water evaporates and you get salt crystals in the air, along with many other things. So it's a very innocuous technology. I think the thing is to get acceptance of it. You know, I mentioned it's being mentioned at things like Reuters and USA Today, newspapers. It's getting some mainstream coverage. I think to get some pilot projects, actually just go and, you know, do it. Just go and make the, you know, and demonstrate that you're actually making clouds and measure the temperatures underneath them, and then just expand it and get some breakthrough in funding. People generally think of funding from countries or, you know, from NASA or NOAA or large organizations, but we just need to convince somebody like Elon Musk, for example, that, hey, this is a good idea and we'll have, you know, we'll be doing it, right, in regions. So funding could be from a multitude of different sources, right?
The Advanced Research and Invention Agency in the UK, who are possibly looking at the need to mitigate extreme weather for the UK, and seeing marine cloud brightening as a very promising contribution to that. So I think one of the points that comes out of Peter's comment is that the world's very polarized over climate change between deniers and decarbonists, but neither of them offer a solution. And we've seen in this last year, with the removal of sulfur from marine shipping, an amazing sudden spike in temperatures. And it's really very concerning about things like the Atlantic meridional overturning circulation and the melting of the Arctic and the growth of extreme weather. So there's a security dimension to climate that hasn't been properly engaged, as Paul alluded to earlier. And so the need for this technology is very high, but at the same time, bringing the public along. And that's where good governance is really essential. So rather than just going out and doing it, there's a really big need to engage in those broader conversations in the media and in politics and academia, to explain the strategic vision and get people on board. Because at the moment, one of the things that Herb has commented about the politics in the USA is that you just never hear about this stuff. There's the media just doesn't cover it. So, I mean, Herb, can you expand on that?
Well, just very briefly, one of the terms I coined in my book, A Climate Vocabulary of the Future, is what I call the climate media omerta, or code of silence. When I first wrote the edition 6 years ago, you could count the number of, literally the number of minutes a year that networks spent on climate. Maybe now it's a couple hours as opposed to a few minutes, and half the time it's on denying it on some of the right-wing networks. So we still have a long way to go. It's a challenge, and I think that we need to be as much focused on on the message as we are on the substance. And, there's plenty of work in both realms. And I wanted to ask before we wrap up, Win or Ali, do you have any other comments, questions you want to make?
I have one comment, which is that one of the invisible funders may well be the insurance industry, because if you can't get insurance, then the insurance companies have no business. And if they try and insure things that are uninsurable, then they go bust. So I can imagine that this rather large industry is going to be very interested to try and stabilize the climate.
Ali, anything?
So yeah, just in response to Peter's question there, I think the polarization of the debate about marine cloud brightening is very important. I went into a rabbit hole this morning and I had a look at a couple of websites. And actually, I found some of the websites, although some of the images and stuff were scary, a lot of the values were the same. So like values were like respect for indigenous people, making sure that you don't have concentrations of power and money that take away people's autonomy. So like all things that I would agree with. So I think there is common ground there. It's like that old parable about the elephants, where one person's holding the tusk and saying, this is really valuable. Another person's on the tail side and they step in the dung and they're going, there's something smells bad here. That if you've got any situation where two people are looking at the same thing and finding something polar opposite, it's because there's a gray bit in the middle that they're not seeing. So in order to see that common gray bit, it's important to explore that without saying that the other person's view is wrong. And at the moment, it's very difficult to even have a conversation with people, because as soon as, I've tried to say this to friends, like, oh, I'm doing this, and then there's this kind of crossed arm thing going on. Oh my gosh, it makes me so sad. But we need to start having these uncomfortable conversations with people and not just saying they're nutters, because often the people who are pushing back the most are people who are wanting nature-based solutions, who are people who really, really care about us destroying ourselves and all of our fellow co-evolved life forms. So we're coming from the exact same thing that we're trying to get to. So if we're seeing something different, it's because there is the common ground is something that we haven't explored and haven't discovered yet. It's there.
It's so true, Ali. And I think Stephen really recognized that marine cloud brightening is something about a change of thinking. And he was good friends, I believe, with James Lovelock and the Gaia hypothesis as a way of understanding that we need to think about our planet in system terms, and seeing our planet as a complex system. One of the most important things is restoring the lost albedo, and MCB is one of the best ways to do that.
Absolutely.
Well, I want to thank everybody. You've literally gathered from all over the world in honor and in memory of Stephen and his extraordinary work. And we've also laid out and heard some very stirring visions of the future. And I just want to leave you with one sort of comment that has to do, you may have heard Stephen say this in the video, but it goes back to what Win and Ali said about how Stephen would teach engineering. So he basically said when he did these sort of calculations about the cost of marine cloud brightening, and he made these calculations at the Glasgow COP, and he calculated that the annual cost of the fleet of ships that Robert and others have referred to, and the maintenance of that fleet in terms of paying back the loans or whatever, is about equal to the cost of the COPs at COP, to the security costs, 1 year of the security costs at Glasgow. I can't imagine a more compelling and disheartening metaphor or comparison, but nonetheless, I believe an accurate one. MCB, if it proves to be successful, and I think most of us are very optimistic about that, but the tests still need to occur, is absolutely affordable by any measure, is safe. As Paul said, it's salt, designer salts, as I call it in my book, and it absolutely has to be looked at as vigorously and with the highest possible priority. So again, my thanks to all of you. My thanks to the Climate Emergency Forum. And you'll see, I'm sure, in the notes on this talk, opportunities to contact Re-brightening and the other folks here, because we want you, when you watch this, not to say, well, what's the next YouTube video coming up in 10 seconds and then forget about it. But to act on what you've heard, that's the only way we're going to have a brighter future for all of us. And if you've learned something from this video, if you heard something that resonated with you, please like the video, please subscribe, and please come back to see our next talk and go back through our library of talks by some extraordinary speakers on some of the most important topics in the world today. So thanks again so much to everyone.